Hi everyone, good morning. Is the audio volume video is everything fine? Please let me know. So this is the part 2 of GoClasses homework 2 solutions. Part 1 you can find in the description. The link of GoClasses homework 2 Boston University questions part 1 you can find in the description, and this is homework 2 part 2. Okay, so some questions were remaining. Those questions I want to discuss in this part. So let's start. Okay, so this is basically I can say homework 2 part 2. Okay, part 1 you can find in the description. So now let's start. So you can notice this was the part 1. You can find this part 1 in the description. Now let me start the part 2. Okay, so this was the question that we did not do in the last class, in the last session. So let's do this let's do this question now. Okay, so let's start. So this was the question. So question number 14. What the question is saying? The question is saying that draw the hash diagram of DFA of with as few states as possible. Basically minimal DFA we have to create for the following languages. Alphabet is 0 comma 1. This is the alphabet. Now let's see L6. What this L6 is saying? Strings. W is a string of the form x1 y1 x2 y2 xn y1 for some natural number n such that xi yi, these are symbols. Remember, xi yi, these are symbols. And the question is saying xi is equal to yi for all I. This is the question. Very simple question. So tell me, did you try this? Did you try this question? First, you understand the language. See, for any in TOC subject, whenever you want to solve any question, first you always understand the language. So let's first understand this language L6. What this language is saying? The language is saying that first of all the alphabet is given to you. The alphabet is 0 comma 1, and the question is saying that there is L6. This is a language, and in this language we have strings. Every string is like this. Every string is like this. In this language every string is like this: x1 y1 x2 y2 x3 y3 and so on xn yn. Okay, where n is some natural number, where n is some natural number. And the question is saying that the question is saying that xi is equal to yi for all I. For all I, xi is equal to yi. So first you understand the language. What do you understand by this language? What do you understand? Remember, every string is like this. Every string is like this: x1 y1 x2 y2 x3 y3 xn yn. Every string is like this. So can you tell me what is the length of every string? So can you tell me what is the length of every string? So what is the length of w? What is the length of w? The length of every string, that is 2n, where n belongs to natural number. So the length of every string is 2n. You can notice in this language. So every string is like this. If I put n equal to 0, remember, first of all it should be given whether 0 is natural number or not. I told you some authors they consider 0 as natural number. Some authors they do not consider 0 as natural number. So let me assume that 0 belongs to natural number. Let me assume. Okay, it is not a problem. Please understand, it is not a problem. Why? Because in the gate exam, in any exam, they will give you whether 0 is natural number or not. Okay, so you don't have to worry about it. But let me assume 0 is a natural number. Let me assume. Okay, now you can notice that the length of w is 2n. Length of every string is 2n, where n is a natural number. Let me assume that 0 belongs to natural number. Let me assume this. Let me make this assumption. If you don't make this assumption, then also there is no problem. Okay, then also you can create the DFA. Now let me assume that this 0 is a natural number. So tell me, in this L6, do we have empty string? Do we have empty string in this language? Because you can notice, if I put n equal to 0, if I put this n equal to 0, because 0 is a natural number, I am assuming, this is my assumption, that 0 is a natural number. Okay, so if I assume 0 is a natural number, then you can notice n can be 0. Then you can notice that the length of w will be 0, and length of w will be 0 means empty string. Length of w will be 0 means empty string. Yes, empty string will be in the language. Correct. Empty string will be in the language, right? Yes or no? If I assume 0 is a natural number, if I assume that n can be 0, if I assume n can be 0, then you can clearly see that if I put n equal to 0, then length of w will be 0. And which string has length 0? Which string has length 0? Tell me. So empty string will belong to language. Yes or no? Is this clear to everyone? See, very simple point what I am saying. I am saying that the length of w is 2n. If you notice, w is x1, y1, x2, y2, x3, y3. And here every xi is a sigma. Here every xi is a sigma. Remember, here every xi is a symbol. Here every xi is a symbol. Okay. Now, you can notice that if I put n equal to 0, then length of w will be 0. Then length of w will be 0. Yes or no? Agree or not? If I put n equal to 0 in this string, if I put n equal to 0, then length of w will be 0. And which string has length 0? So the empty string has length 0. So empty string is in the language. Empty string has length 0. If I put if I put n equal to 1, if I put n equal to 1, so this I will get when I put n equal to 0. If I put n equal to 1, then I will get what? Then I will get 0, 0, 1, 1. This is what I will get when I put n equal to 0. Sorry, this is what I will get when I put n equal to 1. If I put n equal to 1, then length will be 2. Length of string will be 2. So these are the strings I will get, because remember, every string is like this. Every string is x1, y1, x2, y2, x3, y3, and so on, xn, yn, where xi is equal to yi for all I. This is given. This is given in the question. Okay, and remember, every xi means this is a symbol. This is either 0 or 1. This is 0 or 1. This is 0 or 1. Everything is a symbol. So these are symbols. So finally what we have? So we have the when I put n equal to 1, I will get this. If I put n equal to 2, what I will get? If I put n equal to 2, n equal to 2, then I will get 0, 0, 0, 0. I will get 0, 0, 1, 1. I will get 1, 1, 0, 0. And I will get 1, 1, 1, 1. This is what I will get when I put n equal to 2. Yes or no? If I put n equal to 2, I will get total 4 strings I will get. Yes or no? Total 4 strings I am going to get if I put n equal to, if I put n equal to 0, n equal to 2. Then 4 strings I am going to get. You can notice, if I put n equal to 2, okay, then length will be 4. Length of string will be 4. And these 4 strings I will get. And so on. This is your language. Is this infinite language? Can I say this is infinite language? This language, is this infinite? Yes, because remember, n belongs to natural number. Okay, so this n, you can replace this with any natural number. So when you replace this n with any natural number, you can create a string. So finally I can say this will be infinite language. Okay, this is your language. So first you understand the language. This is your question L6. In this question L6, first you clearly understand the language. Okay, this is your first task. Clearly understand the language. This is your language. Okay, yes or no? So in this language, you can notice that every string has length 2n, where n, so every string has length even. And you can notice every string is like this. So like this, for example, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. So this type of strings. So in this language, we have this type of string like 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0. This type of strings we have in this language. Yes or no? This type of strings belong to the language. Now let's create the DFA. Now the DFA creation is very easy. So initial state, I want to accept empty string. In the DFA, if I want to accept empty string, then initial state must be final state. You already know this. Okay, if I want to accept empty string, then initial state must be final state because I want to accept empty string. Now, if if 0 comes, then what I will do? I will wait for another 0. Yes or no? If 0 comes, I will wait for another 0. Correct or not? I have seen 0. I will wait for another 0. So if the symbol 0 comes, I will wait for another 0. If the symbol 0 comes, then I will wait for another 0 because the next symbol must be 0. The next symbol must be 0. If the next symbol is 1, then what should I do? If the next symbol is 1, like after 0, if the symbol 1 comes, like after 0, if symbol 1 comes, then what should I do? I should go to dead state because now there is no chance of accepting. I should go to dead state because there is no chance of acceptance. Now there is no chance of acceptance. After 0, if 1 comes, now there is no chance of acceptance. Okay. Now after 0, if another 0 comes, what should I do? If another 0 comes, then again I will, okay, then I will go here. So you can notice after 0, if another 0 comes, then I will go to initial state because in the initial state everything is perfect. Like I can say this initial state is saying that everything is perfect. So far these things are in the coming in group. Initial state is saying that so far everything is coming in group. Okay, so you can notice if another 0 comes, I will go here. If the first symbol is 1, what should I do? If the first symbol is 1, tell me. If the first symbol is 1, if the first symbol is 1, then what should I do? Then I should wait for another one. If the first symbol is 1, then I should wait for another one. The next symbol must be 1. But if the next symbol is 0, if the next symbol is 0, then I should go to dead state. After 1, if 0 comes, I should go to dead state because there is no chance of acceptance. After 1, if 0 comes, now whatever comes, there is no chance of acceptance. So I should go to, so I can say that we should go to, okay, dead state. After 1, if another one comes, then what should I do? After 1, if another one comes, I can go here. After 1, if another one comes, I will go here. This is your DFA. That's it. So how many states we have? So number of states, that is 4. Let's check. Is this minimal DFA? Let us check. Let us check. Is this minimal DFA? So you tell me. Okay. All the GoClasses students, please tell me. Okay, this state we don't have to compare with anyone. Yes or no? This state we don't have to compare this state with anyone because this is the final state. No one else is final state. So this state is, okay, this state must be in the minimal DFA. We cannot merge this state with anyone. This state is not equivalent to anyone. So this state will be there in the minimal DFA. Okay, so we have to compare. For example, these two states, if I compare, are they equivalent? These two states, this state and this state, are they equivalent? No, they are not equivalent, right? They are distinguishable by 0. I can say they are distinguishable by 0. This state, let me call it state q0, let me call it state q1, let me call it q3, let me call it q3, and let me call it q2. So you can notice that I can say, what can I say? I can say that some extra things I can say. I can say q1 is not equivalent to q3. This state q1, this state q1 is not equivalent to q3, and they are distinguishable by whom? They are distinguishable by whom? They are distinguishable by 0 because q1 on 0 is going to final state and this q3 on 0 is going to non-final state. So they are distinguishable by 0. Correct? They are distinguishable by, they are distinguishable by 0. And what about q1 comma q2? What about q1 comma q2? They are distinguishable by 1. What about q1 comma q2? They are distinguishable by 1. Q1 comma q2, because this q2 on 1 is going to final state and this q1 on 1 is going to non-final state. And q2 comma q3 are, q2 is not equivalent to q3. They are distinguishable by whom? They are distinguishable by 1. I can say they are distinguishable by 1 because q3 on 1 is going to non-final state and q2 on 1 is going to final state. So this is your answer. So number of states will be 4. Okay, is this clear to everyone? Is it clear? If if 0 is not a natural number, then what will be the answer? If 0 is not, if you don't take 0 as a natural number, if you don't take, okay, if you don't take 0 as a natural number, if 0 does not belong to natural number, if you don't take this 0 as a natural number, then what will be the L6? Then L6 will be, remember, then empty string will not belong to L6. Now I'm, okay, L6 will be like this. Now L6 will be like this. So this will be your L6 now. This will happen when you put n equal to 1. This will happen, and after that 0 0 0 0 0 0 1 1 1 1 0 0 1 1 1 1. Okay, like this, these type of things, these things will happen, these strings will come when you put n equal to 2. Okay, so if you assume 0 is not a natural number, if you assume 0 is not a natural number, if you assume, then what will be the answer? Then what will be the DFA? The only change will be, now initial state cannot be final state. Now initial state cannot be final state. So basically a new initial state you will create. Okay, this is the change will happen. After 0, if another 0 comes, you will go to final state. Okay, similarly, so after 0, if another 0 comes, then you will go to final state. Because remember, now initial state cannot be final state. You cannot make initial state as final state. Okay, similarly after 1, if another 1 comes, you will go to final state. After 1, if another 1 comes, you will go to final state. Okay, and you can notice that in this state, if 0 comes, you will go here, you will wait for 0. Okay, remember, yes or no? See, in this state, what I am doing, in this state I have seen 0, I am waiting for 0. In this state I have seen 1, I am waiting for 1. So in this state, if 1 comes, I will go here. If 1 comes, I will go here, and there will be a dead state, and there will be a dead state. We will have, we will also have a dead state, because in this state, you can notice, in this state, in this state, if 0 comes, you will go to dead state, and in this state, if 1 comes, you will go to dead state. So in this situation, if you assume empty string is not in the language, then number of states will be what? Then number of states will be 5. So is this question clear to everyone? Let me know. Please tell me, is this question clear? Anyone has any doubt in this? Very simple variation, very simple question. So first you understand the language, and then you create the DFA. Okay. Vani is asking 0011, how it is satisfying. See, the language L6, the language L6 is saying that every string is like this. See, Vani, every string is like this: x1 y1, x2 y2, x3 y3, x3 y3, and so on and so on, xn yn. Okay, where n belongs to, where n belongs to set of natural number, and xi is equal to yi, xi is equal to yi. And remember, xi comma yi, these are symbols. Remember, xi yi, these are symbols. These are 0 comma 1, these are 0 comma 1. So you can notice that, remember, xi is equal to yi means x1 is equal to y1, x2 is equal to y2. It's like this, it's like this: x1 y1, x2 y2, x3 y3. Okay, it is like this, it is like this, such that these are same, these two symbols must be same, these two symbols must be same, these two symbols must be same, and so on and so on, these two symbols must be same. Is it clear? So you can notice 0011, you can notice these two symbols are same, you can notice these two symbols are same. This 0011 I can write as x1 y1, x2 y2. Basically n is equal to 2. Basically I am taking n is equal to 2. If you take n equal to 2, then you will get x1 y1, x2 y2, and you can notice these two must be same, and these two must be same. So finally 0011, this is also in the language. Anyone has any doubt in this? Is it clear? Let me know. Is this question clear to everyone? If you assume 0 belongs to natural number, if you assume, see, if you assume 0 belongs to natural number, then number of states will be 4. Then this DFA you will get number of states will be 4, And if you assume 0 is not a natural number, then number of states will be 5. Okay, so this is your question. Is this question number L6? Is it clear? Question number L6. So very simple question. Very easily you can create the DFA. We have created many DFA. Okay, and you don't have to create NFA. Remember, you don't have to do this. You don't have to do this. Like, you don't have to create NFA, then you convert into DFA, and then you minimize. Then you minimize. Okay, you don't have to do this. You don't have to do this. You can directly create the DFA. From the language, you can directly create the minimal DFA. We have created many minimal DFA directly. A lot of, in our class, in our lectures, in our previous homework sessions, we have created many DFA. Many DFA we have created, many minimal DFA we have created directly from the language. Understand the language, create the DFA. That's it. Okay, this is the idea. Is it clear? Let me know. Now in this question L6, let's create a variation. Shall we create a variation? In this question number L6, let's see a variation of L6. Let's see a variation of L6. What is the variation of L6? This is the variation. Let me create new language L, and this is like this. Those strings such that every string is like this: x1 y1, x2 y2, and so on, xn yn. Every string is like this. Okay, every string is like this. And let us assume xi is not equal to yi. Let's assume xi is not equal to yi for all I. Now what is the language? Now you again understand the language. Let us assume n. Okay, let us assume n belongs to natural number, and let's assume 0 is also a natural number. Let's assume 0 is also natural number. Now you understand the language. Tell me, what is the language? Now remember, xi is not equal to yi. This is your language. Now in this language we have this type of string. Remember, xi yi, these are symbols. xi yi, xi yi, these are symbols. These are 0 or 1. Okay, these are 0 or 1. Now we have this type of strings. In this language we have this type of strings: x1 y1, x2 y2, x3 y3, and so on, xn yn. This type of strings we have, where these are not equal, where these are not equal, where these are not equal. Okay, where these are not equal, and where these are not equal. So this type of strings we have in this language. So in this language L, now what we have this type of strings. Like, if I put n equal to 0, if I put n equal to 0, I will get empty string. Yes or no? Because the length of every string is what? Please understand, the length of every string is what? In this, if you notice, the length of every string, is 2n. If I put n equal to 0, if I put this n equal to 0, then I will get empty string. So you can notice, if I put n equal to 0, I will get empty string. Okay, now what is the next? If I put n equal to 1, then what I will get? Tell me. If I put n equal to 1, how many strings I will get? If I put n equal to 1, then I will get 0 1. I will also get 1 0. These two strings I will get if I put n equal to 1. And if I put n equal to 2, then what I will get? If I put n equal to 2, I will get 0 1 0 1, 0 1 1 0, 1 0 0 1, 1 0 1 0. These strings I will get when I put n equal to 2. Correct? I will get these strings when I put n equal to 2. Okay, so like this is your language. So once you understand the language, you can create the DFA. Let's create the DFA. So okay, remember, in this language we have this type of strings. Strings are like this. 0 followed by 1, 0 followed by 1, 1 followed by 0, 1 followed by 0, 1 followed by 0, 0 followed by 1, 1 followed by 0, 0 followed by 1, 0 followed by 1. Okay, 1 followed by 0. So this type of strings we have in this language. In this language we have this type of strings. Now let's create the DFA. So what your DFA will be? For this language L, what the DFA will be? The DFA is very simple. We have to accept the empty string. So if you want to accept the empty string, then in the DFA, initial state must be final state. In DFA, in any DFA, if you want to accept empty string, then initial state must be final state. Okay. In DFA, empty string is accepted if and only if initial state is final state. Okay. In this state, if 0 comes, in this state, if 0 comes, I will wait for 0. I have seen, I am waiting for 1. I will wait for 1, right? I will wait for 1. In this state, if 1 comes, if 1 comes, I have seen 1. I have seen 1. I will wait for 0. I will wait for 0. Okay. In this state, I am waiting for 1. If 0 comes, I will go to dead state. After 0, if 2 consecutive 0 comes, if 2 consecutive 0 comes, I will go to dead state. Similarly, if 2 consecutive 1 comes, I will go to dead state. Okay, because if consecutive 0 comes, there is no chance of acceptance. If consecutive 1 comes, there is no chance of acceptance. Okay. Now, in this state, if 1 comes, I am waiting for 1. In this state, if 1 comes, then no problem. Okay, just go here. Just go here. Okay, just go here. And in this state, if 0 comes, just go here. Tell me, in this language, can consecutive 1 happen? In this language, consecutive ones can come or not? Consecutive ones can come or not? In this language, tell me. In this language, consecutive ones, they can come or not? Yes, they can come, right? Yes, they can come. Like, okay, consecutive ones can come. Basically, what I want to say, I want to say that this any string, I want to say that any string you divide into two cells. Every string you divide into two cells. Okay, this is what I'm saying. Every string you divide into two cells. So let's assume this is your string. This string you divide into two cells. This string you divide into two cells. You divide this string you divide into two cells. And now what should happen? Now this should happen. Now this should happen. If this is 0, this should be 1. If this is 1, this should be 0. If this is 1, this should be 0. If this is 0, this should be 1. If this is 1, this should be 0. Okay. So first you understand the language. Once you understand the language, you can create the DFA very easily. In the initial state, if 0 comes, I will wait for 1. If 1 comes, then that is fine. That is fine. Here everything is fine. Here everything is fine. Okay. Now in the initial state, if 1 comes, I will wait for 0. If 0 comes, I will go to the fine state. After 1, if this 1 comes, then I will go to dead state. And similarly, after 0, I am waiting for 1. After 0, I am waiting for 1. But if 0 comes, I will go to dead state. This is your DFA. So these are regular languages. Yes or no? These two languages, can you notice? These two languages are regular languages. Like we have seen L6 and we have seen L6 variation. These are regular languages because we can create DFA. These languages are regular languages. Yes or no? These are regular languages. These two languages are regular languages because there exists a DFA. Because they can be accepted by DFA, we can create DFA for them. So these are regular languages. Now let's see the next question. Okay, this is your question number L6. I hope this question is clear. We have done the complete analysis. And what is most important in this question? Can anyone tell me? In this question, in many questions, what is the most important thing? That is understanding the language. Understanding the language is most important. Understand the language. That is the most important part. In most of the questions, in many questions, understand the language. That is the most important part. Let's see the question number B, L7. W. W represents a binary number that is congruent to 1 modulo 3. What it means? Congruent to 1 modulo 3. It means when you divide the number by 3, then remainder must be 1. In other words, okay, so this is given to you. The number is presented starting from the most significant bit and can have leading zeros. Can have leading zeros. Okay, it can have leading zeros. So let's see the question number L7. Let's solve the question number L7. So the question number L7, first you understand the language again. L7. What this L7 is saying? L7 is saying that every string is over 0, 1 because your alphabet is 0, 1. So we have strings of 0, 1. These are strings of 0, 1 such that okay, if you interpret this as a binary, basically decimal value of 0, decimal value of W, basically decimal value of W, when you divide by 3, the decimal value, when you divide by 3, then remainder must be 1. This is what the question is saying. Okay, this is what the question is saying. So first you tell me, first you understand the language, which strings are in the language, which strings are in the language. So remember, those strings are in the language whose decimal values should be what? Those strings are in the language whose decimal value is what? Those strings whose decimal value is what? Whose decimal value is, I can say, decimal value is 1, or decimal value is 4, or decimal value is 7, or decimal value is 10 or 13. So the decimal value is like this. So these strings are in the language. In this language, we have these strings whose decimal value is this. So for example, okay, for example, and in this question also it should be mentioned. Let me tell you, in these type of questions, empty strings should be there or not? Tell me, in these type of questions, there is no information for the empty string. There is no information for the empty string. So empty string should be accepted or not? There is no information about the empty string. So there is no information about the empty string. So tell me, empty string should be accepted or not? Empty string should be accepted or not? So let me tell you, in these type of languages, okay, in the, like, what is the decimal value of empty string? Can anyone tell me? Anyone want to tell me what is the decimal value of empty string? What is the decimal value of empty string? Of empty string. Decimal value of empty string. Can anyone tell me? What is the decimal value of empty string? So let me tell you, it should be given. It should be given. Yes or no? Nonsense. Because this is empty string. There is no symbol here. We don't have any symbol. So decimal value of empty string is, okay, is generally taken as 0. Is generally taken as 0. Is by default taken as 0. Is by default taken as 0. Is it clear? Remember, the decimal value of empty string is generally, or I can say by default, taken as 0 in this type of languages. Okay, so this, in this type of languages, if the decimal, if there is no information about the empty string, if we don't have any information about the empty string, then it is generally taken by, it is generally taken as 0. And what is length of empty string? What is length of empty string? That is 0. There is no problem. That is 0. That is 0. The length of empty string, that is 0. But remember, the decimal value of empty string, the decimal value of empty string, that is generally taken as 0. Generally, generally it is taken as 0. Generally it is taken as 0. Okay. So if no information is given about the decimal value of empty string, whether empty string should be accepted or not, okay, then you can take the decimal value of empty string as 0. Is it clear to everyone? So it is generally, it is taken as 0. Okay. Now let's see. So let's move on. So let's see now. So first you understand the language. So you can notice that empty string does not belong to the language because the remainder must be 1. We want the remainder to be 1. When you divide the decimal value by 3, the remainder should be 1. So this string will be in the language, and leading zeros are allowed. Remember, leading zeros are allowed. In the question it is saying, leading can have leading zeros. Can have leading zeros. Leading zeros can be there. Okay, can have leading zeros. So leading zeros are allowed. So the 001, this is also fine. 0001, this is also fine. Okay, next you can notice 100, this is also fine. 0100, this is also fine. 00100, this is also fine. 111, this is also fine. 111, this is also fine. Okay, I can say this type of strings we have in the language. In the language we have this type of strings, correct? Now let's create the DFA for L6. For L7, this is your language L7. So let's create the DFA for L7. So how to create? Very simple. I told you the DFA creation is very easy task. Very easy task. So we don't want to accept empty string. Empty string we don't want to accept. So you can create, basically when you divide by 3, there are 3 possible remainders. Either the remainder will be 0 or the remainder will be 1 when you divide by 3. When you divide any number by 3, then possible remainders are 2. Possible remainders are 3: remainder 0, remainder 1, remainder 2. Okay, now if symbol 0 comes, if any number of 0 comes, then remainder is 0. If any number of 0 comes, then remainder will be 0. Yes or no? Remainder will be 0 if any number of 0 comes. If any number of 0 comes, remainder, the decimal value will be 0, and when you divide by 3, then remainder will be 0. Okay, you can notice the decimal value is 0 for this string. The decimal value is 0, and when you divide by 3, then the remainder will be 0. Okay, after this, if 1 comes, in this state, if 1 comes, means after 0, if 1 comes, now the decimal value is 1, and when you divide by 3, then remainder will be 1. Okay, so in this state, if 1 comes, I will go to remainder 1 state. Now this state is done. In this state, for every alphabet symbol, we have created transition. In this state, for every alphabet symbol, we have created transition. So this state is over. Now in this state, what you have seen, what this state is telling you, this state is telling you, I have seen 1, I have seen 1, I have seen 1. If you give me 0, now the decimal value will be 2. Now the decimal value will be 2, and if you divide by 3, then the remainder will be 2. So if you give me 0, I will go to remainder 2. What this state is telling you, this state is telling you, I have seen 1, I have seen 1. If you give me 1, decimal value will be 3. Decimal value will be 3. So remainder will be 0. So I will go to remainder 0 state. Okay. So this state is done. Next, what this state is telling you, this state is saying that I have seen 1 0. This state is saying that I have seen 1 0. I have seen 1 followed by 0. I have seen 1 followed by 0. If you give me 0, now the decimal value will be 4. Now the decimal value is 4. When you divide by 3, then the remainder will be 1. The remainder will be 1. So if you give me 0, I will go to remainder 1 state. What this state is telling you, this state is telling you, I have seen 1 0. If you give me 1, now the decimal value is 5. Decimal value is 5, and if you divide by 3, then the remainder will be 2. This is your DFA. That's it. Okay, and the final state will be, this will be the final state. Okay, very simple. Anyone has any doubt in this? This is your question. Very simple question. Okay, we have created this type of questions. Actually, this is decimal divisibility language, and this type of question we have done many times. Many times we have seen this type of questions. Okay, so anyway, this is your L6 L7. Anyone has any doubt in this L6 L7? Question number 14, L6 L7. We have seen L6, we have seen L7. We have seen variation of L6. So both of these are regular languages because you can create DFA for them. Anyone has any doubt in this L6 L7? Yuvraj, any doubt? Okay, let's see the next question. This is another very easy question. W represents a binary number that is divisible by n. This is regular. How to prove this is regular? How to prove? Leading zeros can be there. Leading zeros can be there, and this should be divisible by n. This should be divisible by n. Means, okay, means you have those strings whose decimal value is divisible by n. So we need to prove this is regular, and we have already done this. Yes or no? We have already done this. So you can create a DFA of any state. This string, this language, remember this language. What this language is? Language is W belongs to 0 1 star, means W is a string of 0 1. W is a string. W is a string of 0 1. A string of 0 1s. 0 1s. Okay. Now the question is saying that W represents a binary number that is divisible by n. Okay, means basically what the question is saying. The question is saying that W is a binary number, okay, which is divisible by n. Means the decimal value of W, when you divide by n, then the remainder is 0. When you divide by n, then the remainder will be 0. This is your language. And for this language, you can create a DFA of n state. For this language, you can create a n state DFA. You can create n state DFA. What will be n states? Because you are dividing by n. You are dividing by n. So when you divide any number by n, any number when you divide by n, then possible remainders are 0, possible remainders, the possible remainders are 0, 1, 2, and so on, n minus n, n minus 1. These are the possible remainders. This is your initial state, and you can create the transitions. You can very easily create the transitions. Okay, some transitions you can create. Okay, so like this you can create the transitions very easily. So this will be your DFA. You can create a DFA basically. Basically you can create a DFA. And because you can create a DFA, so because there is a exist a DFA, okay, because there is a DFA, so L is regular. Because there is a DFA, so L is regular. Now tell me this point. Is this minimal DFA? Is this minimal DFA? I am saying this is a DFA. I am saying this is an state DFA. But is this minimal DFA? Is it minimal DFA? No. Okay, remember this need not be minimal DFA. This n state DFA, this may not be minimal DFA. This may not be minimal DFA. I told you this in the class. In the lectures I told you this is decimal divisibility language. Okay, remember I told you these two languages I told you. One language I told you, two languages I told you. One was counting symbols. One language was counting symbols language. Okay, one language is counting symbols language. Counting symbols, counting length. So one language was this, modulo counting. Okay, modulo counting. This was one language, modulo counting. Okay, modulo counting. So this was one language, modulo counting. In this language, you know, I told you that if you have this type of string, like for example, all these, I told you this is what I told you, that W such that length of W mod n, length of W mod n is equal to some remainder r, okay, or maybe 0. Length of W when you divide by n, this should be 0. Now for this minimal DFA has n states. Remember, minimal DFA has n states. For this minimal DFA has n states. Similarly here, okay, W such that number of edge in W, number of edge in W mod, number of edge in W mod n equal to 0. For this also minimal DFA has n states. This we have already seen. We have already seen in the class. Okay, and another language is decimal divisibility language. Another language is decimal divisibility language. In this you find out the decimal value. This is decimal, or I can say divisibility language. In this I told you that we have a okay, minimal DFA. If I give you this language, for example, if I give you this language W, which belongs to 0 1 whole star, okay, such that decimal value of W mod n is equal to 0. Okay, I told you that for this we have n state DFA is there, but it need not be minimal. We have n state DFA, okay, but it may not be minimal. It may not be minimal. It may not be minimal. So minimal DFA will have how many states? Minimal DFA, number of states. Minimal DFA will have how many states? Number of states will be less than equal to n. Okay, minimal DFA will have less than equal to n states. This is your decimal divisibility language we have already seen. Okay, very simple. Now let's see, let's move on. Okay, so basically the question is asking, prove that it is regular. Yes, it is regular. Yes, it will be regular because you have a DFA, because you can create a DFA. This DFA may not be minimal. Remember, this n state DFA, this may not be minimal. This may not be minimal. Okay, so you have to minimize this. You have to minimize it. Okay, so this is the difference between divisibility language and counting symbols. Modulo counting. This is modulo counting. Here you are doing modulo counting, and this is divisibility. These are different languages. Okay, now this is the next question, and this is very interesting question. Very interesting question, and the question is asking, can you create DFA for this language? Can you create DFA to recognize addition? Can you create DFA to recognize addition? Create a DFA to recognize addition. So this is a very nice question. Let me try this. Okay, let me tell you, before you solve this question, you should watch this video. This video you should watch. So on GoClasses YouTube channel, the link is in the description. You can find the link in the description. you should watch this video. In this video, I have created Mealy machine, Murray machine for integer addition. Okay, for addition of two integers, I have created Mealy machine, Murray machine. This is what I have created in this video. You can watch it on GoClasses YouTube channel. You can find this Mealy machine, Murray machine, finite state machine. This playlist you can find on the GoClasses YouTube channel. In this playlist, you have total 16 videos. A lot of questions I have solved. Okay, so we have studied what is Mealy machine, what is Murray machine, how to create Mealy machine, Murray machine. Okay, everything we have seen in this playlist. You can watch it. Okay, now let's come back to the question. So the question is saying that this is your language. Your language is W. W is a string of the form x1 y1 z1 x2 y2 z2 xn yn zn for some natural number n such that x plus y equal to z as binary numbers. Okay, here x, y, z are presented starting from least significant bit. Remember, x, y, z, these are presented starting from least significant bit and can have trailing zeros. This is the question. Let's see this question. First, you understand the language, what the language is saying. The language is saying that every string is like this. The language is saying every string is like this: x1, y1, z1, okay, x1, y1, z1, x2, y2, z2, and so on, xn, yn, zn. This is your string. This is every string is like this. Every string is like this. And the question is saying that what should happen? What should happen? This should happen that x plus y should be equal to z as binary numbers. Means it should happen. See, this x is like this. This x is basically like this. And remember, this is the given. This is given x, y, z. These are presented. Starting from least significant bit. Starting from least significant bit. It means this is the least significant bit of x. What it means? It means this is the least significant bit of x. Okay, so first you understand the language. This is the least significant bit of x, and this is the most significant bit of x. Similarly, this is the least significant bit of y. Okay, and this is the most significant bit of y. Okay, and similarly you can notice this is the least significant bit of z, and this is the most significant bit of z. Okay, now let's understand this language. So this language is saying that basically x is like this. X is okay. So let me do this. I think okay. So now let's see. So this x is like this. X is like this. So tell me what will be x? Tell me what will be x? X will be x1, x2. Okay, should I write like that? No, it will be like this. It will be like this: xn, okay, then xn minus 1, and so on, x1. Okay, y will be like this: yn, yn minus 1, and so on, y1. And z will be like this: zn, zn minus 1, z1. This is the idea. And what the question is saying? The question is saying that x plus y should be equal to z. X plus y, this should be equal to z. Okay, so let's try to understand the question. So what the question is saying? In the question, which type of strings? First of all, you tell me in this language L, what is the length of every string? What is the length of every string? First you tell me this point. Tell me this point. What is the length of every string? What is the length of every string? You can notice the length of every string: x1, y1, z1, x2, y2, z2, xn, yn, zn. So the length of every string is 3n, correct? The length of every string is 3n, where n is a natural number. The length is 3n, correct? The length is 3n. Length is multiple of 3. Okay. And what this question is saying? The question is actually like this. So you take two numbers x, y, and you do their addition. What you do? You have x, you have y. There is a number x, there is a binary number y, and you do their addition, you will get z. Okay. And then from that you can create the string. For example, the question is like this. This question is saying that you take x. For example, let me take x 0, 1. Let me take y, that is 1, 0. Then what will be z? Tell me. If this is x 0 1 1 0, then what will be z? What will be z? 0 1 1 0, you do their addition, then you will get 1 1. So z will be 1 1. Z will be 1 1. So which strings you will get because of this? In L, which strings you will get? In this language L, what you will get because of these? Because of these, in L, what you will get? Remember, x is a binary string, y is a binary string, and their addition should be equal to z. Read the question. Please read the question very carefully. Create a DFA recognizing the language addition. Recognizing this language where W is a string, of the form x1 y1 z1 x2 y2 z2 and so on for some natural number n, such that x plus y equal to z as binary numbers, such that x plus y equal to z as binary numbers. X, y, z are given starting from least significant bit, and they can have trailing zeros. Like this type of zeros they can have, trailing zeros they can have. So because of this situation, if I take x equal to 0 1, y equal to 1 0, then z will be 1 1. So because of these, what string I will get in L? I will get this string in L. Okay, remember x1 y1. So I will get like this 1 0 1 followed by 0 1 1. This string I will get in the language, correct? Yes or no? This string I will get in the language. Because of this, I will get this string. Yes or no? Starting from LSB, I will get this string 1 0 1 0 1 1. Is it clear? Ashish, Akash, please notice, if your string is like this, please first you understand that if your string is like this, x, if x is equal to, like this, y is equal to like this, okay, then z will be, then z will be, then remember what we are doing? We are writing them least significant bit first. Please read this, starting with the least significant bit. Please read this. XYZ, they are presented, XYZ are presented starting from least significant bit. Least significant bit. Least significant bit. This is the least significant bit. This is called least significant bit. This is called most significant bit. So remember, this is called most significant bit. This is called least significant. This is called least significant bit. Okay. So your string will be like this. This string you will get in the language because of this x comma y. Because of this x comma y, you will get this string in the language. Now tell me, because of this x comma y, which string you will get in the language? If if I give you x, let's assume x is this. Let's assume x is this, and let's assume y is this. Then what string you will get? Tell me. What will be z? Z will be what? So you do their addition. 1 0 0 1 plus 0 1 0 1. You do their addition. So 1 plus 1, that will be 0. Carry will be 1. Carry will be 1. 0 plus 1, that will be 1. 1 plus 0, that will be 1. So your Z will be this. So because of this, which string you will get in the language? Because of this, in the language, which string you will get? In the language, which string you will get in the language? Which string you will get? So starting from LSB. So first you will get 1 1 1, okay, followed by 0 0 0, followed by 0 1 1, followed by, okay, so followed by, remember, followed by 0 1 1 and followed by 1 0 1. This string you will get, correct or not? So because of this addition, you will get this string, correct or not? This string you will get. Yes or no? Is it clear to everyone? Let me know. Remember one more thing. Every string has length what? The length of every string is what? That is 3n. That is multiple of 3. Okay, so this string you will get 1 1 1 0 0 0, then 0 1 1, then 1 0 1. Oh, sorry. So did I do some mistake? Okay. So correct. So this will be 1 0. So this will be 1 0. So the string that I will get, what string I will get? I will get this string. I will get 1 1 0 followed by 0 0 1 followed by 0 1 1 followed by 1 0 1. This string I will get. Okay. Yes. Okay. Correct. So this string I will get. So now you are getting the idea, right? What strings are in the language? What strings are not in the language? For example, okay. Let me assume if x is this and if y is this, then what will be z? Tell me. If x is this, if x is this and y is this, then what will be z? 1 plus 0, that will be 1. 1 plus 1, that will be 0, and there will be out carry. There will be out carry, that is 1. So tell me, will we have this in the language? Because of this, because of this, will we get any string in the language? In the language, are we going to get any string because of this? Will we get any string because of this? No, right? We will not get any string because of this. Because every string in this language, if you notice, every string in this language, if you notice, that has length 3n. That is multiple of 3. That is multiple of 3. Okay. So this, because of this, no string we will get in the language. Because of this, there will be no string in L. Because of this, correct or not? Because of this, there will be no string in L. Because remember, the question is saying that x plus y should be equal to z. The question is saying that x plus y should be equal to z. X plus y must be equal to z. So because of this, we cannot get any string in the language. Because of this, if x is this and y is this, then z will be 1 0 1. Now you cannot get any string in the language. So what basically what we are saying? So what is happening here? Why there is no string in L? Tell me why there is no string in L? Why? Why there is no string in L? If there is a out carry, if there is a final carry, I can say, if there is a final carry. So I can say if there is a final carry, if there is a final carry, if there is a final carry, then does not belong to language L. Yes or no? Then it will not belong to language L. Means final carry must be what? It must be 0. Yes or no? If you want to belong to L, then final carry must be 0. So how to handle this? Tell me. How to handle this? If I want this, if I want these two, if I want to do their addition, then how to handle this? Means final carry must be 0. Agree? Final carry must be 0. Final carry must be 0. Final carry must be 0. So how to handle this? Please tell me. If I want to do their addition in this language, if I want to put their addition, then what to do? Put a 0. Yes, very good. Yes, very good. Prepend a 0. Remember, the question is saying can have trailing zeros. The question is saying can have trailing zeros. Okay. So the question is saying that you can put extra zeros, you can put. Now you can do like this. This x you can take, this y you can take. Now the z will be 1 0 1. Okay, now everything is fine. So now what string you will get in L? Because of this, in L, what string you will get? You will get this string 1 0 1 followed by 1 1 0 followed by 0 0 1. This string you will get in the language. This string you are going to get in the language. Okay. So this is the idea. I hope this idea is clear. So did you understand the language? Let me know. Finally, did you understand the language? What this language is saying? The language is saying that x plus y should be equal to z. And you can notice the length of w must be equal to multiple of 3. Okay, the length of w, that must be multiple of 3. And you can notice this is the most significant bit of z. This is the MSB of z. And you can notice this is the LSB of x. This is the LSB of x. And you can notice x plus y should be equal to z. So what strings? Tell me, what strings we have in the language? We have empty string. We have empty string in the language. Why there is empty string in the language? Tell me. Why there is empty string in the language? Tell me. Because if you put n equal to 0, if you put n equal to 0, then there will be empty string. Okay. So there is no problem. Basically, if if 0 belongs to natural number, then empty string will be in the language. If 0 does not belong to the natural number, then empty string will not be in the language. Let me assume 0 belongs to natural number. Let me assume 0 belongs to natural number. Let me assume. So you can notice empty string will be in the language. Why? Because if I put n equal to 0, then length of w will be 0. Which string has length 0? Remember, the length of w is 3n, multiple of 3. So if I put n equal to 0, then length of w will be 0. And which string has length 0? That is empty string. So this empty string you will get when you put n equal to 0. If I put n equal to 1, which string I will get? Which strings I will get if I put n equal to 1? If I put n equal to 1, if I put n equal to 1, which strings I will get? Remember, if I put n equal to 1, then which strings I will get? I will get these strings. 0 plus 0, addition is 0. 0 plus 1, addition is 1. 1 plus 0, addition is 1. These strings I will get. These I will get. This is what I will not get. 1 plus 1. This will be 1, 0. And because of this, there will be nothing. Okay, this does not belong to language L. I can say this does not belong to language L. So what strings I will get? You can notice I will get 0, 0, 0. I will get 0, 0, 0. I will get 0, 1, 0. I will get 1, 0, 1, 0, 1. Sorry, I will get 0, 0, 0. I will get 0, 1, 1. I will also get 1, 1. I will also get 1, 0, 1. So these strings I will get. Very good. Yuvraj, very good. So these strings I will get when I put n equal to 1. Then this string I will get, this string I will get, this string I will get. Okay, similarly, if I put n equal to 2, then which strings I will get? If I put n equal to 2, in this language, if I put n equal to 2, so if I put n equal to 2, then which strings I will get? For example, this type of strings like 0, 0 plus, okay, then addition will be 0, 0. So because of this, I will get this string. This string I will get because of this. And if I do 0, 0 plus this, then I will get this string. So because of this, what I will get? Because of this, I will get 0, 1, 1, 0, 0, 0. This is what I will get. And similarly, you can notice if I have 0, 1 plus 0, 1, then what string I will get? I will get this string. So finally, what string I will get? I will get 1, 1, 0, 0, 0, 1. So like this I'm doing. Okay, yes or no? Like for example, 0, 0 plus 1, 1. So what I will get? I will get 1, 1. So what string I will get? I will get this string 0, 1, 1, 0, 1, 1, and so on, and so on. So these strings you are getting correct, like 0, 1, 1, 0, 0, 0. Okay, I can say 0, 1, 1, 0, 0, 0. Similarly, I can say 0, 0, 0, 0, 0, 0. Similarly, I can say 0, 1, 1, 0, 1, 1. Correct? So like this. I hope you understood the language. Did you understand the language? Now we will create the DFA. First you understand the language, then we create the DFA. Did you understand the language? Can you say you understood the language? Okay, now let's create the DFA. Now we will create a DFA. When we create a DFA, what is very crucial? Actually, if you notice, apart from the numbers, these numbers x plus y equal to z, apart from these numbers, what we have to keep track of in the when you are creating DFA, what you have to keep track of? What you have to keep track of? We have to keep track of carry, yes or no? We have to keep track of carry. We have to keep track of carry. We have to keep track of. Okay, carry can be 0. Either the carry will be 0 or the carry will be 1. We have to keep track of carry. Either the carry will be 0 or the carry will be 1. We have to keep track of carry, correct? Don't forget about carry. We have to keep track of carry. So there will be one state where carry is 0, another state where carry is 1. Yes or no? We have to keep track of carry. Carry is very important. This carry is very important when you are doing addition. Whenever you are doing addition, carry is very important. For example, if you are doing addition like this, if you are if you are doing addition of these two numbers, if you are doing addition of these two numbers, then carry is very important. Carry is very important. 1 plus 1, that will be 0, and carry will be 1. 1 plus 1, that will be 0, carry will be 1. 1 plus 1, that will be 0, carry will be 1. 1 plus 1 plus 1, that will be 1, and carry will be 1. So this carry we have to keep track of. We must keep track of carry, correct? So let's create the DFA. Now the DFA creation is very easy. So there will be one state. Initially the carry is 0. Can I say initially the carry is 0? Initially the carry is 0, right? So initially the carry is a 0. So let me make initially carry is 0. Initially the carry is 0, and this is the state where carry is 1. This is the state where carry is 1. So initially carry is 0. This is the initial state where carry is 0. Okay, now tell me, in this initial state where carry is 0, if the first symbol is 0, what should I do? If the first symbol is 0, it is like this. If the first symbol is 0, like if the first symbol is 0, it means the LSB of x is 0. If the first symbol is 0. And tell me one more thing, the final carry must be what? When you are creating DFA, the final carry must be what? Tell me, which will be the final state? Final state will be what? Final state will be carry 0 state. Yes or no? Carry 0 state must be the final state, because finally carry must be 0. This we have already seen. Finally carry must be 0. So this carry 0 state will be the final state. This will be the final state, carry 0 state. Okay, finally carry must be 0. Okay, now if the first symbol is 0, then what should happen? If the first symbol is 0, then what I will do? If the first symbol is 0, then I will see the next symbol. Then I will see the next symbol. If the next symbol is also 0, then what I will do? Then the carry will be 0. Yes or no? If the first symbol is 0 and the next symbol is 0, then if the first symbol is 0, next symbol is 0, then the next symbol must be what? Then the next symbol must be what? Tell me. If the first symbol is 0, okay, this is your x, this is your y. If the first symbol is 0, second symbol is 0. First symbol 0 means that this is the LSB of x. Second symbol means LSB of y. Then the result must be 0. Result must be 0. Result must be 0. So in this state, result must be 0. Okay. In this state, if 1 comes, then what should happen? In this state, if 1 comes, in this state, if 1 comes, then what should happen? In this state, if 1 comes, then I will go to dead state. Then I will go to dead state, correct? Because after 0, 0, it's like this. After 0, 0, if 1 comes, this cannot happen. This cannot happen. Because if you do addition of 0, 0, and the carry is 0, and the carry is 0, and the carry is 0, carry is 0. So the addition must be 0. So basically, if 1 comes, I will go to dead state. So if I see 0, 0, then it must be 0. After 0, if I see 1, then what should happen? After 0, if I see 1, like after 0, after this 0, if I see 1, after this 0, if I see 1, then what should happen? If I see 1 in this state, then what should happen? Then the result must be 0, because the carry is 0. Remember, carry is 0. Remember, carry is 0. Carry is 0. So the result must be 1. The result must be 1. In this state, if 0 comes, then what should happen? In this state, if 0 comes, I will go to dead state. Correct? In this state, if 0 comes, I will go to dead state. Now you can notice this state is done. This state is over. This state is over. This is dead state. This is over. This state is over. Okay, so these states are over. All these states are over. Now tell me, in this state, in the carry 0 state, in the carry 0 state, if the first symbol is 1, if the first symbol is 1, now tell me, if the first symbol is 1, in this carry 0 state, in the carry 0 state, if the first symbol is 1, then what should happen? Then let us assume second symbol is 0. If the second symbol is 0, now what should be the next symbol? What should be the next symbol? Remember, carry 0. I am talking about carry 0 state. This is the carry 0 state. In the carry 0 state, in the carry 0 state, if the first symbol is 1, second symbol is 0, then what should be the next symbol? The next symbol must be 1. The next symbol must be 1. And where will I go? The next symbol must be 1. And carry will be what? And carry will be 1. Yes or no? The next symbol will be 1 and the carry will be 1. Next symbol will, next symbol will be 1 and the carry will be 0. The carry will be 0. Okay, very simple. After 1, if the first symbol is 1, after 1, if the second symbol is 0, if the second symbol is 1, after 1, if the second symbol is 1, after 1, if the second symbol is 1, now tell me, if the second symbol is 1, after 1, if the second symbol is 1, then the result must be what? Then result must be 0. The result must be 0, but carry must be 1. Please remember, result must be 0, the next symbol must be 0, next symbol must be 0, but now I will go to carry 1. I will go to carry 1 state. Let me know, is it clear? See, very simple, this idea is very simple. This, did you understand what is happening here? Now you can notice that this state is done, this state is done, every state is done, yes or no? In this state, if 1 comes, I will go to dead state. In this state, if 1 comes, I will go to dead state. So every state is done. In this state also, if in this state, if 0 comes, I will go to dead state. So you can notice every state is done, every state is over, yes or no? For the carry 0, every state is over. Did you understand? Anyone has any doubt? Let me know. Anyone has any doubt? What is happening here? This is what I'm saying. See, idea is very simple. Idea is very simple. Basically, if the first symbol is 0 and second symbol is 0, let us assume carry 0. Let us assume I am talking about carry 0. Let's talk about carry 0 state. Let's look at carry 0 state. So what will happen in the carry 0 state? You can notice if the first symbol is 0, second symbol is 0, then this symbol must be 0, because the carry is already, I am talking about carry 0 state, means carry is already 0, means the carry is already 0. Okay, so you can notice if I do 0 plus 0, it should be 0, it should be 0. Okay, and if I do 0 plus 0 and if I see 1, then this should go to dead state. This should go to dead state. If I see 1, this should go to dead state. Similarly, if the first symbol is 0, the second symbol is 1, then the result must be 1. Result must be 1. And this carry will be what? This carry is already 0 and this carry will also be 0. So in the carry 0 state, this is happening. What I am saying. See, very simple point. So you can similarly see 0 plus 1. If this is 0, then this will go to dead state. Then I should definitely go to dead state, because the carry, I am talking about carry 0 state. Okay, because I am talking about carry 0 state. So I should go to dead state. So did you understand this carry 0 state? Tell me, please tell me. This carry 0 state we have done. Now let's fill the carry 1 state. So we have already seen carry 0 state. This carry 0 state is already done. Okay, so this carry 0 state we have already seen. All the transitions we have already seen. Let's assume. Okay, so all the transitions we have already seen. What will happen here? Now let's see the carry 1 state. Now let me talk about carry 1 state. In the carry 1 state, now the carry is 1. Now the carry is 1. Now you tell me if the carry is 1. So tell me in the carry 1 state. In the carry 1 state, what will happen? Tell me. Means already your previous carry is 1. Already the previous carry is 1. Already your previous carry is 1. So if you do 0 plus 0, then result must be 1. Then the result must be 1. And next carry will be, I will go to which state? I will go to which state? Tell me. I will go to which state? The next carry will be 0. The next carry will be 0. So I will go to carry 0 state. So in this carry 1 state, if the first symbol is 0 and next symbol is 0, then the next symbol must be what? The next symbol must be 1. And I will go to carry 0 state. Yes or no? In this carry 1 state, if the first symbol is 0, second symbol is 0, then next symbol must be 1. Next symbol must be 1, because this is the carry 1 state. I am talking about carry 1 state. Okay, so 0 plus 0 plus 1. So that will be 1. But next carry will be 0. So I will go to carry 0 state. In this carry 1 state, this is the carry 1 state. If I do 0 plus 1, then what should happen? The result must be 0 and I will go to carry 1 state. Yes or no? So in the after 0 if 1 comes, then the result must be what? Then the result must be 0 and I will go to carry 1 state. I will go to carry 1 state. Result will be 0, but I will go to carry 1 state. In this state, if 1 comes, I will go to dead state. I will go to dead state if in this state if 1 comes. Similarly, in this state if 0 comes, I will go to dead state. Okay, it's very simple. This is very simple. And similarly, in this state if 1 comes, in the carry 1 state, if 1 comes, in this carry 1 state, This is your carry 1 state. If 1 comma 0 comes, then result will be 0. Result will be 0, but I will go to carry 1 state. So after 1 if 0 comes, after 1 if 0 comes, then the next symbol must be 0. Next symbol must be 0. Next symbol must be 0, but I will go to carry 1 state. After 0 if after 1 if 1 comes, okay, remember carry 1 state. After 1 if 1 comes, then the result also will be 1, and I will go to carry 1 state. After 1 if 1 comes, after 1 if 1 comes, then the next symbol must be 1. Next symbol must be 1. Next symbol must be 1, and I will go to carry 1 state. Okay, so you can notice in this state if 0 comes, I will go to dead state. In this state if 1 comes, I will go to dead state. This is your carry 1 state. Everything is done. So that's it. So did you understand this question? Very nice question. I hope you enjoyed this question. So finally, this is your diagram. Let me create the final diagram. Let me give you the final diagram. The final diagram is like this. See, for this question, the final diagram is like this. So you have two state. There are carry 0 state, carry 1 state. So first you what to do? You create carry 0 state. So there are two states. Remember, there are two states. One is carry 0 state, one is carry 1 state. So let me create. This is your carry 0 state. This is your initial state. And this is also your final state. Because the final carry we want 0. The final carry must be 0. Yes or no? The final carry must be 0. So this is your final state also. There is another state that is carry 1 state. There is another state that is carry 1 state. Now what you can do very easily, in this carry 0 state if 0 comes, in this state if 0 comes, then if the next symbol is also 0, then the next symbol must be 1. Okay, in this state if 0 comes and next symbol is also 0, then next symbol must be 0. Then next symbol must be 0. Okay, next symbol must be 0. I can say that next symbol must be 0. Next symbol must be 0. Okay, next in this after 0 if 1 comes, after 0 if 1 comes, this is the carry 0 state. This is the carry 0 state. So after 0 if 1 comes, then the next symbol must be 1, and the carry will be 0. Okay, in the carry 0 state, you know, in the carry 0 state, this you already know. In the carry 0 state, the carry is already 0. So the next symbol will be 1, and then I will go to carry 0 state. I will go to carry 0 state. Okay, so very simple. Now similarly in this state if 1 comes, in this state if 1 comes and then next is 0, then I will go to carry 0 state. Then the next symbol must be 1, and I will go to carry 0 state. But after 1 if 1 comes, after 1 if 1 comes, then what I will do? After 1 if 1 comes, after 1 if 1 comes, then the next symbol must be 0, but I will go to carry 1 state. Next symbol must be 0, and I will go to carry 1 state. Okay, very simple. And the remaining arrows, the remaining will be the dead state. The remaining things will go to the dead state. So there will be a dead state. You can create a dead state. The remaining things will be the dead state. For example, in this state if 1 comes, dead state. In this state 0 comes, dead state. Okay, so these are the dead states. You can notice the remaining things will go to the dead state. In this state if 0 comes, dead state. In this state if 1 comes, dead state. This is your carry 0. Now similarly you can create the carry 1 state. In the carry 1 state you can notice, if in the carry 1 state if 0 comes, in this state if 0 comes, then in this state if 0 comes, and let's assume next symbol is 0, then in the carry 1 state, I am talking about carry 1 state. I am talking about carry 1 state. So after this is the carry 1 state. This is the carry 1 state. So the next symbol must be 1. Next symbol must be 1, and I will go to carry 0 state. I will go to carry 0 state. So after 0, if next symbol, okay, now in this situation, what I will do? I will go to carry 0 state. So this is what I will do. In this state, if 0 comes and then again 0 comes, then the next symbol must be 1. Next symbol must be 1, and I will go to carry 0 state. After 0 if 1 comes, after 0 if 1 comes, after 0 if 1 comes, then next symbol must be 0, and I will go to carry 1 state. In this state if 1 comes and after that 0 comes, then next symbol must be 0. Next symbol must be 0, I will go to carry 1 state. After 1, if 1 comes, then next symbol must be 1, and I will go to carry 1 state, and the remaining arrows will go to the dead state. All the remaining arrows, they will go to the dead state. Like in this state, if 1 comes, dead state. In this state, if 0 comes, dead state. Okay, all the remaining arrows will go to the dead state. So this is the idea. I hope you got it. Let me know. Anyone has any doubt in this? So finally what we have done, so you can recognize addition using DFA. So we have created a DFA which will recognize this addition. So this is your question, this is your answer. Now tell me one more thing, one variation. Let me see one variation. Let me ask you one variation. Let me ask you one variation. If this type of strings also we want to accept, this is one variation. If we want to accept this type of, if we want to accept this type of strings, for example, let us assume x is 1 0, let us assume y is 1 1, then what will be z? What will be z? Z will be 1, that will be 1 0 1. Okay, this will be z. If I want to accept this, basically if I want to accept this type of strings, basically forget about this. Okay, if I discard this, if I discard the final carry, if I discard this carry, if I discard this carry, and if I want to accept this, basically if I want to accept this 0 1 1 1 1 0, if I want to accept this type of strings, are you getting my point? Are you getting my point? This is my point, that if we just want to accept this type of strings, like okay, the final carry we will discard, but we want to accept the remaining thing, this remaining thing we want to accept. So if we want to accept this string, for example, if I want to accept this string also, like 1 plus 1, so you know that will be 0 1. If I want to accept this string, means if I want to accept 1 1 0, if I want to accept this, if we want to accept this string, then what should I do? Then in this DFA, what changes I have to do? In this DFA, what changes I have to do? In this DFA, what changes I have to do? If I want to accept, basically this final carry I will discard, this I will discard, but if I want to accept this type of strings, okay, the final carry I will discard, and if I want to accept this remaining thing, then what I will do in this DFA, what I will do? No, the carry 1 state will be the final state. This also will become, these two will become the final state. Both of them will become the final state, yes or no? Now even if the final carry is 1, that is also fine, yes or no? Basically if the final carry is 1, that is also fine. Basically if final carry is 1, that is also fine. Basically if final carry is 1, if final carry is 1, that is also fine. That is also fine. Okay, means if the final carry is 1, for example, you can notice 1 0 1, 1 plus 1 plus 1. Okay, if the final carry is 1, that is also fine. So I will just accept this. I will just accept this. So I will accept 1 1 0, 0 1 0, and 1 1 1. So this I will accept. Okay, this I will accept. So what I will do? Tell me what I will do. Very simple. This carry 1 also will become the final state. This is the only change. This is the only change. Okay, carry 0 comma carry 1, both these state will become final state. This is the only change. There is no other change. This is the only change. Okay, let me know, did you understand this solution, this language? Did you understand this solution, this language? So did you understand this question? The question was this. This was our question. This is the original question. You can read this question, and the question is asking, create a DFA to recognize addition. Create a DFA to recognize addition. So we have created a DFA which recognizes addition. So tell me one thing, please tell me one thing. You have seen the solution. Okay, I told you the solution. I told you many examples, what strings are in the language, what strings are not in the language. Okay, I told you everything. Now you tell me one thing. Was this complicated to understand? This you tell me. Like, see what I'm saying. See the DFA. Don't worry about DFA. Don't worry about DFA. I'm asking this language. When you read this language, is it complicated to understand? See, the everything is given in the question. The question is very well framed. This is Boston University homework question. This is a very nice question. In the question, every information is given that you have x, you have y, their addition must be z. Strings are given starting from LSB, starting from least significant bit, starting from LSB. So every information is given to you. In the question, every information is given to you. Every string will have length 3n, multiple of 3. Okay. So every information is given in the question. So now you tell me, did you understand the question? Did you understand which strings are in the language, which strings are not in the language? Okay. Did you understand the DFA? Did you understand that the carry 0 will be the final state? Because ultimately final carry must be 0. Final carry must be 0. Yes or no? Final carry must be 0. Correct? So final carry must be 0. So carry 0 will be the final state. And carry 1 state will not be the final state, because the final carry must be 0. Okay, so then we have created transition. Very simple. In every state we are seeing what is happening. Okay, so we have created the DFA. So now tell me, did you understand all these things? And one variation also we have seen. What is the variation? If we want to accept, if we want to discard the final carry, just discard the final carry. Okay, forget about the final carry. Discard the final carry. Okay, just give me the result. Just give me the n bit result. You have n bit number plus n bit number. The final result will have n plus 1 bit. The final result, it can have n plus 1 bit, but discard the final carry. Just give me the n bit plus n bit, the n bit result. You just give me that. So that is another variation. And in that variation, what will happen? The final carry equal to 1 is also allowed. We don't have any problem. The final carry equal to 1, that is also allowed. So what we will do in that variation, what we will do? We will create two final state. Final carry equal to 0, final carry equal to 1. These will be the final state in that language. Okay, in that variation. So now you tell me, did you understand? This is a very nice question. I hope you got it. No, this question will not come in the GATE exam. Arnav. Arnav is saying homework this type, then what would be the exam level question? No. This question will not come in the GATE exam. This question is not going to come in the GATE exam. This is for your practice. This is for your knowledge. This will not come in the GATE exam. Don't worry about it. But in the GATE exam, what they can ask you? They will not ask you to create the DFA. They will not ask you to create the DFA. They will not ask you number of state in the DFA. They will not ask you this. But what they can ask you? Can anyone tell me? In this question, the GATE exam, what it can ask you? It can ask you, is this regular language or not? This language they will give you, and they will ask you, is this regular language or not? So this language is regular. Okay? Is this clear? This language is regular. Now let me tell you few things, few very interesting things. We have seen the DFA, but now the interesting part will come. Now the interesting part is going to come. See, many students, they by heart this statement. DFA finite automata can do addition. See, many students what they do. Many students what they do. They by heart this statement. Many students what they do. They by heart this statement. They will by heart. They will by heart this statement. Either this statement or this statement they will by heart in their notes. Okay, many students they will by heart from their notes. So they will write this in the notes. So they will write this type of things in the notes, like finite automata cannot do addition. Cannot do addition. This type of statements they will write in the notes. Finite automata cannot do addition. So they will by heart this statement. This statement they will by heart. Okay, they will by heart this statement. The finite automata cannot do addition. Or they will by heart this statement. I don't know, like which statement they will by heart. I don't know. Finite automata can do addition. So either they will by heart this statement, or they will by heart this statement. Okay. So I know, I have seen many students, they either they by heart this, their finite automata cannot do addition, or they will by heart this finite automata can do addition. Can you tell me which statement is correct? Can you tell me from these two statements which statement is correct? Can you tell me from these two statements which statement is correct? Finite automata cannot do addition, finite automata can do addition. Which statement is correct? Which of them is statement is correct? Let me tell you, both of them are nonsense. Let me tell you, both of them are nonsense. Both of them are nonsense statements. Both of them are nonsense. First of all, these are nonsense statements. Why these are nonsense statements? Let me tell you. Okay, let me tell you why these are nonsense statements. Okay, so let me tell you. The reason, let me tell you. The reason is this. After some time, we will see that this language is not regular. See, what we have seen, this language is regular, right? This we have already seen, W, okay, such that x1, y1, z1, x2, y2, z2, x2, y2, z2, correct? x2, y2, z2, x3, y3, z3, and so on. Okay, and so on. Xn, yn, zn. So this language we have already seen. This is regular, right? This language we have already seen, correct? X plus y equal to z. X plus y equal to z. Okay, here you can notice x plus y equal to z. So this language is recognizing addition. This language, if you notice, this language is recognizing addition. We are recognizing addition. Okay, so x plus y equal to z. So we have already created, this language is regular. We already know this language is regular. So for this language, we have already created DFA. So this DFA is recognizing addition. This DFA is recognizing addition. Okay, this DFA that we have created, that is recognizing addition, correct or not? Okay, let me tell you, after some time we will see this, because in our GoClasses Theory of Computation 2023 course, so far we have seen DFA, we have seen NFA, but I will tell you there is something called pumping lemma. We will study the concept of pumping lemma, the concept of Mealy theorem, and we will see which languages are regular, which languages are not regular. One demo I have already given to you in the lectures. We have already given the proof of a power n, b power n. This is not regular. I gave you this proof. The formal proof I have given to you. Okay. Very simple. The proof we have already seen. Now, what I am saying, we will see another lecture where we will study which languages are regular, which languages are not regular. Okay. And let me tell you that when we study that, many students, they by heart this, like which language is regular, which language is not regular. This type of concepts they will by heart. They will by heart. Okay, finite automata cannot do multiplication, cannot do comparison, 2 comparison, 3 comparison, 4 comparison. This type of things they will by heart. Many students by heart these type of things. And let me tell you that you should not by heart these things. You should understand the question, you should analyze the question, and then you should solve it. Let me give you one more thing. So you can notice this language, this is the language, and in this language we have a DFA which is recognizing addition. We have created a DFA which is recognizing addition. Let me give you another language. And this language is like this. This language is like this. X1, x2, xn hash y1, y2, yn hash z1, z2, zn, such that x plus y equal to z. Is this regular? See, please understand what is the difference. This language is regular. X1, y1, z1, x2, y2, z2, x3, y3, z3. This language is regular. This language. In this language also we are doing addition. In this language also we are doing addition, and this language is regular. Now look at this language. Look at this language. Look at this language. X1, x2, xn, some symbol, y1, y2, yn, some symbol, z2, z1, z2, zn. Now you tell me, such that x plus y equal to z. After some time, using pumping lemma, we will prove it. Don't worry about it. Don't worry about it. We will prove it. Using pumping lemma, using Mealy theorem, we will prove it after some lectures. We will see this in our GoClasses Theory of Computation lectures. We will see this. We will see that this is non-regular. This is non-regular. There is no DFA for this language. For this language, there is no DFA. For this language, there is no DFA. There is no finite automata for this language. Now you tell me, so can I say finite automata cannot do? See, if you see this language, you are thinking finite automata can do addition. Yes or no? Agree or not? When you see this language, for this language, we have already created DFA. For this language, you are thinking finite automata can do addition, can do addition, can do addition. Now, I am giving you new language, a new language I am giving you. In this new language, what I have? I have this X followed by Y followed by Z. X followed by Y followed by Z. And this language is non-regular. For this language, there is no finite automata. So when you see this language, then what you will think? When you see this language, what you will think? You will think finite automata cannot do addition. So tell me which is correct. Now tell me which is correct. Tell me which is correct. Finite automata can do addition or cannot do addition. So did you understand the difference between these two languages? Remember, one language is like this. In one language, what we are doing, I am giving you these three things, okay, together. Like I am giving you these three things. In one language, I am giving you these three things. Okay, see, in one language, in this language, what I am doing, I am giving you first, I am giving you this, okay, then I am giving you this, and then I am giving you this. Correct or not? This is what I am doing. Okay, I am giving you this. In this another language, what I am doing, in this another language, what I am doing, in this another language, first I am giving you this, then I am giving you this, and then I am giving you this. So did you understand the difference between these three languages, these two languages? So this language is regular. Why this language is regular? Can anyone tell me? Because in this language, you tell me one thing. In this language, once we are done with these, see, once we are done with this, do we care about it? Like once we are here, do we care about this? We don't care about this. Yes or no? We don't care about this. So once you are here, for example, once you are here, you don't care about these. Yes or no? You don't care about these. So what I'm saying, in this language, when I'm giving you this, then I'm giving you this, then I'm giving you this. So in this language, at any point of time, how many things you have to remember? In this language, at any point of time, how many things you have to remember? At any point of time, how many things you have to remember? At any point of time. At any point of time, how many things? You have to remember what is the carry, what is the previous carry, and what are these three. Yes or no? You have to remember four things. You have to, at any point of time, you have to remember four things. In this language, if you notice, at any point of time, four things you have to remember. You have to look at four things. You only have to look at four things. What are these? The four things are, what is the in carry, what is the incoming carry, and what is your xi, what is your yi, and what is your zi. Only these things you have to consider. You only have to look at these four things. Okay, very simple. But in this language L2, look at this language L2. In this language L2, what is happening? In this language L2, what you have to do? In this language L2, you have to remember the complete X, because first I will give you the complete X. Remember, yes or no? In this language L2, if you notice, first I will give you the complete X. First you have to remember the complete X. You have to remember. Okay. Then I will give you the complete Y. After that, you have to calculate the Z. Can you do this? Can a finite automata do this? See, can a finite automata do this? What your finite automata will do? See, this is your L2. In this L2, first I will give you this X. Then I will give you this Y. And then I will give you this Z. Now you tell me, what your finite automata? Okay, see, very simple. Finite automata goes from left to right. Goes like this. So when finite automata is here, when finite automata is here, okay, so let's assume finite automata is here. Now it want to do the addition, yes or no? Your finite automata is here. Let's assume finite automata is here. Now this finite automata want to do addition. X is there, Y is there. Now your finite automata has to do addition. Now your finite automata has to do addition. But at this time, your finite automata cannot go back, yes or no? At this time, your finite automata cannot go back. Your finite automata cannot go back. At this time, your finite automata cannot know what is X, what is Y. Yes or no? Is it clear to everyone? See, finite automata is going from left to right. Okay, so when it comes to Z, now it needs to do addition. Now it needs to do addition. Now it needs to do addition. Okay, now you need to do addition. So you can notice that now you cannot go back, but you cannot go back. But we cannot go back. So that is the reason this language is not regular. You cannot create DFA for this language. So I hope you understood the difference between this language and this language. Okay, is it clear to everyone? So this is the idea. Now remember, now let me tell you one thing. So why this is nonsense? If you by heart, then this is nonsense. If you by heart these statements, these two statements, if you by heart, then these are nonsense. So you should not by heart these, yes or no? This is my idea. This is my point. Did you understand what point I am saying? I am saying don't by heart. Whatever language is given to you, understand that language, analyze that language, and then you find the answer. So problem is by hearting. Problem is this. Don't by heart this type of statement like finite automata can do addition, cannot do addition, can do multiplication, cannot do multiplication. Finite automata can do comparison, cannot do comparison, 2 comparison, 3 comparison, addition, multiplication, division. These type of concepts, these type of things, you should not by heart. If you understand them, then it is good. Okay, if you by heart them, then it is bad. Okay, so if you by heart, then it is nonsense. Please remember, if you by heart, then it is nonsense. If you by heart, then you will make a mistake. If you by heart, then you will make a mistake. Okay, so if you don't by heart, if you by heart, then you will make a mistake. And if you don't by heart, then you can solve the question. Whatever language is given to you, you can solve it. For example, if this language is given to you, then you will say, though, so this is non-regular. In this language, addition is happening. In this language also addition is happening. But this language is regular because in this language, we are only thinking about 3 things at a time. Okay, only 3 things at a time. Only 3 things at a time. Okay, so in this language, if you notice, we are looking at 3 things at a time. At a time, we are looking at 3 things. Okay, 3 things at a time in this language. I hope this point is clear. But in this language, you can notice first entire X, then entire Y, then entire Z. So this language is non-regular. Okay, so that's it. So this is the final point. Now the final point. Okay, if this statement is there, finite automata can do addition. Finite automata can do addition. So what will be your answer? Finite automata can do addition. Finite automata can do addition. What will be your answer? The answer will be yes. Yes, finite automata can do addition. DFA can do addition. Okay, because, but what you have to do? For this addition, what you have to do? The answer will be yes. Finite automata can do addition. The answer will be yes. The answer will be yes. But if finite automata has to do addition, if finite automata has to do addition, then what should happen? Then what should happen? If finite automata has to do addition, then what should happen? You should give me like this. The input should be given like this. The input must be given like this. The input must be given like following. So the input must be given like this. Okay, means you should give me input like this. X, Y, Z. This is your X. This is your Y. This is your Z. Now the input must be given like this. Like this, the input must be given. Okay, so first give me this. then give me this. So this is the idea. Then give me this. Okay, so the input must be given like this. The input must be given like this. Okay, so that's it. So if anyone asks you finite automata can do addition, yes, it can do addition, but you should give the input. But remember, the input you should give like this. Okay, you should give the input like this, like whatever input you have. For example, if your x is 1 0 0 1 and if your y is 0 1 1 1, then what will be z? Z will be 0 0 0. Okay, so let's assume this is also 0. So what will be your z? Z will be 0 0 1 1. This will be z. Now, so the input, if you give input like this, then finite automata can do addition. See, if input is given like this, if input is given like this, like if I give input like this, 1 1 0 followed by 0 1 0 followed by 0 0 1 followed by 1 0 1. If I give input like this, then yes, finite automata can do addition. Yes, FA can do addition. FA can do addition. But if you give the input like this, if input is given like this, if input is given like this, first you give x, then you give y, and then you give z. If the input is given like this, then finite automata cannot do addition. So if input is given like this, remember, if input is given like this, okay, then finite automata cannot do addition. Okay, so that's it. Okay, so this is your homework. Let me know, do you have any doubt in this homework? Do you have any doubt? Anyone has any doubt in this homework? This is your Go classes homework 1, homework 2, solution session part 2. Okay, so the part 1 you can find in the description, the part 1 link. So this is your complete solution of the homework 2. So anyone has any doubt, let me know. Did you understand in this lecture, in this session, did you understand few things about DFA, how the DFA, how the finite automata behaves? Okay, how to create DFA. So these concepts, did you understand? We have seen some beautiful questions in this session, some very nice, some very beautiful questions we have seen. And can you notice that in all these questions that we have seen in this session, in all these questions, understanding language is very important, yes or no? Understanding the language is very important. So the first step, remember, you always, first you understand the language. First, always understand the language. Understanding the language is extremely important. Understand the language, this is extremely important. Once you understand the language, you can answer any question, then you answer the questions. So first you understand your language, then you answer questions. Okay, so this question I am giving you as a homework. This is your question number 17. You can use product automata here. Okay, so should I explain this question? Tell me, this question number 17, can you do? Question number 17, this is the last question of homework 2. This is the last question of homework 2. So you can create product automata for this. The question is saying W contains substring 100 and 10 which do not overlap, which do not overlap. Okay, so the first you understand the language and then you create the DFA. So you can create product automata, but when you create product automata, the DFA will not be minimal. Remember, the DFA will not be minimal if you create product automata. Okay, so let me just see, let me quickly see. So if you create, first you create containing substring 100, you create a DFA for containing you create a DFA for containing 100. Okay, containing 100. Then you create a DFA for containing 10 which do not overlap. What this means, let me tell you what this means. 100 which do not overlap, what this means? It means like this, it means like this. See, this string should not be accepted. This string should not be accepted. Basically, which do not overlap means this 10 has individual identity. This 10 has individual identity. This 10 has individual existence. Okay, it means that 1000 here there is no 10 individually. Yes or no? Yes or no? There is no 10 individually. There is no 10 individually. But you should have 10 individually. This is fine. This string must be accepted. Similarly, this string must be accepted. Similarly, this string must be accepted. Okay, are you getting my point? So I can say, so first you create a DFA containing 100. Then you create a DFA. Then you create a DFA which either contain 101, which either contain 101 or ends with 10, or ends with 10, which either contain 101, which either contain 101 or ends with 10. Okay, so if you contain 101, then there is 10 individually. There is individual existence of 10, and if you end with 10, then also there is individual existence of 10. So you create this DFA, you create this DFA. From these two DFA, you can create product automata. You can create product automata, and that product automata you have to minimize. Don't worry, this question will not come in the GATE exam. Remember, this question, don't worry about it. This question will not come in the GATE exam. Okay, in the GATE exam, all the questions that will come, you can create direct DFA. Let me tell you, in GATE exam, all the standard questions will come, and some easy, basically easy questions will come. They will not give you unnecessarily complicated questions in the GATE exam. In the GATE exam, whatever question comes, you can directly create the minimal DFA. You can directly create the minimal DFA, whatever question comes in the GATE exam. Okay, you can check. We have already created many minimal DFA directly from the language. You don't have to create NFA and then NFA to DFA and then minimize the DFA. You don't have to do that. Okay, in the GATE exam, you can solve all the GATE exam questions. You can solve each and every GATE exam question. You can solve each and every question. You can solve. Okay, each and every question. You can directly create the minimal DFA from the language. Directly minimal DFA you can create. And this is what we have done in our lectures. We have created many minimal DFA we have created directly from the language. Okay, so this we have already seen how to create minimal DFA directly from the language. So all the GATE questions, so you don't have to worry about the GATE exam, but this question you can take as a practice. For this question, you create this DFA, you create this DFA, and then you create product automata, and then you check is it minimal or not. Then you check minimal or not. You check it is minimal or not. Okay, and we know how to check it. Okay, so you have to find the equivalent states. In this D1 cross D2, you have to find out which states are equivalent, which states are equivalent, which states are not equivalent. This is what you have to find out, and then you have to minimize. Okay, so that's it. This is your uh, this is your complete homework. So if anyone is watching this video, okay, and you want to understand, if you want to study theory of computation, if you want to understand the concepts like decidability, okay, concepts like finite automata, PDA pushdown automata, I can say Mealy-Nerod theorem, pumping lemma, okay, all these concepts like decidability, countability, if you want to understand, truly understand, if you don't want to by heart, if you don't want to by heart, if you don't want to remember the tables, if you don't want to by heart the tables of decidability, if you want to understand every concept, then you can join our course. This is our theory of computation course link. The link you can find it in the description. Okay, this link you can find in the description. You can find in this link you can find in the description. Okay, so you can join this theory of computation course. In this course, everything you will understand. This is what I am saying. You will understand everything. Whatever concept, decidability, countability, Rice theorem, whatever concept is there, you will understand. You will not by heart tables, you will not by heart theorems, you will understand everything. Okay, so this is our theory of computation course link. You can find in the description. Okay, and also you can subscribe to our GoClasses YouTube channel. On the GoClasses YouTube channel, there is a TOC homework solution playlist on our GoClasses YouTube channel. Okay, so you can visit GoClasses YouTube channel. There you will find this TOC homework solution playlist. Okay, in this homework solution playlist, standard question session we are solving standard questions. Okay, so from many standard resources like Peter Lynch, Cambridge University, Stanford University. okay, Boston University, IIT, NPTL. So many standard questions we are solving in this playlist. Okay, okay, okay. So there is our Android app also. So you can go to GoClasses. You can go to Play Store. On the Play Store, you can find the GoClasses Android app. So you can download and you can watch the videos. Okay. So this is the test series. All the links are in the description. All the links, the link of test series, the link of Android app, okay, the link of complete course, GATE 2023 complete course, the link of theory of computation course link. All the links are in the description. Okay, and also GoClasses complete discrete mathematics and C programming. These two courses are freely available for all the students. Okay, complete discrete mathematics and C programming. These two courses are freely available for all the learners. Okay, all you have to do, just visit GoClasses website, and there you can find out discrete mathematics and C programming courses. These two courses completely freely completely these are freely available. All the lecture, all the lectures, lecture videos, lecture notes, homework, weekly quizzes, everything is freely available for all the learners. Okay, okay. Thank you everyone. Anyone has any doubt, let me know. Okay. Yuvraj, Akash, any doubt, anyone? If anyone has any doubt, you can put your doubt in the comments. I will answer it. Okay. But I think everything I have explained. Using examples, we have taken many examples, and using examples, I have told you, first we have understood the language, then we have created the DFA. Okay. Some very nice questions we have seen in this lecture, in this session. These questions will not come in the GATE exam directly. Okay, they will not ask you number of states in the DFA for addition, but they can ask you, they will give you the language and they will ask you, is it regular or not? Okay, so what I am saying, that you should not by heart. Whatever you study, you should understand everything. Whatever you study, never by heart. Don't by heart any table, don't by heart any theorem, any formula, any procedure, any algorithm. Don't by heart anything. Understand everything. Okay. Okay, thank you everyone. Okay. See you in the next session. So you can subscribe to GoClasses YouTube channel. On the YouTube channel, you will get all the information about the future sessions. There will be many sessions in the future also. Okay, like there will be this is the homework 2 solution session. So we have seen homework 1, homework 2. These two homework solutions we have seen, and homework 3, homework 4, and all the future homeworks, their solutions we will solve, we will see on the GoClasses YouTube channel. So please subscribe to our GoClasses YouTube channel and share with all your friends, all the GATE aspirants, all the computer science people. Like, okay, basically it's not only about GATE, it's not only about those students who are preparing for the GATE exam. Anyone who is a computer science student, anyone who wants to study theory of computation for their semester exam, or maybe for GATE exam, or for TIFR exam, ISRO exam, any other exam. Okay, if you want to understand, if you want to study theory of computation, this subject, if you want to understand every concept, decidability, countability, pumping lemma, Mahel-Neror theorem, PDA, pushdown automata, DPDA, every concept, if you want to understand, then you can join our theory of computation course. You can also join our GATE 2023 complete course, you can join. Okay, in that complete course, all the subjects are there. You can join that course also. All the links are in the description. Every link is available in the description. You can also join our Telegram group. For the Telegram group also, the link is in the description. So you can join our Telegram group. There you can ask all your doubts. If you have any doubt related to any question related to our courses, any doubt you have, you can ask in that Telegram group. You can join the Telegram group, which the link is in the description. Link of everything is in the description, and this is our GATE 2023 complete course. Okay.